to go ahead and get started.
All right, sure. Thank you so much, everyone, for joining in today. As Nathan said, my name is Momal Ijaz. I am a machine learning engineer at super.ai, and I'm also proactively working as an MLOps lead at a local generative AI-based startup, which is primarily involved in working on relevant generative AI stuff like Stability AI does, as in stable diffusion-based applications. So just to give you like a high-level idea of who I am and how I got, all enthusiastic about LLMs and everything. So during my journey as a machine learning engineer at super.ai, which is data processing and data labeling startup based out of Germany, I was given a task of parsing PDF documents and like extracting different fields or information from those PDF documents and like parsing it and saving it into Excel files. And the state-of-the-art network at that time from Microsoft Research was Layout LM for doing that, which is a deep learning neural network architecture and AI thing, which actually takes a PDF document and in the output, it gives you the fields that you want to extract. But there were a lot of challenges involved in actually pulling that off because a PDF document structure varies from document to document and use case to use case. So there were a lot of things that we tried, but none of them gave us like good results which we could actually deploy to production. And I'd say this is like just one of the use cases that made me realize that we need a off-the-shelf zero-shot capability solution which can do these kind of things really betterly. But yeah, I'm not going to bore you with this PDF story and all. But of course, we all know LLM's boom started off back in November last year when OpenAI actually released ChatGPT. Before that, nobody actually knew what language models are or what large language models per se are. So yeah, I actually don't want to go too technical. I actually don't also want to keep it really naive or layman. So thank you so much, everyone who have joined in and for answering the question of what your domain is. Either you have any far-fetched relationship with the CS domain, or have you ever heard the word LLM, or you have like just joined this webinar out of curiosity to learn what an LLM is, stuff like that. So I'll try to make sure that I try to deliver the information that I have in such a way that that the content that I'm delivering is of utility to everyone in the audience today. So yeah, with that, I guess I can start off. So as we go through the webinar with time. But for starters, we're going to start off with the basics of introduction, like why do we even need LLMs? How do they came into being, and where do they stand in terms of the AI revolution in today's world? So Steve Jobs, in his good old days, mentioned that if we imagine a world where we can mimic human cognitive processes, and we can have emotional attachments to chatbot therapists, or where computers can play chess, write mathematical proofs, or pass exams, and you can even get investment advice from an artificial intelligence. So this was the limit of fictional success that one could imagine, and artificial intelligence, luckily in today's world, has made it possible to achieve all these very simply and very clearly. It happened back in 1965, but there was a very clear difference between what happened back then and what's happening now. So back in heuristic problem solving by computer. This paper was written by Carnegie Institute of Technology in 1965, where they actually put up a simple program which was capable of proving theorems in geometry or discovering deep checkmating combinations. It was basically capable of doing all reasoning related intelligence tasks that one could think of. But so this thing of LLMs, it's not like out of the blue. It's not like it's happening in the world for the first time. It has happened before, but there's something different this time. And that is we have a single large language model that can do it all. So before I go to the next slides or anything, who in the audience knows what a language model is? Let's start with the basics. You can drop a response as if I have no absolute clue that what a language model is, but if you know, you can, if you can describe what a language model is in just a single line, in as simple words as you can, how would you describe it as per your understanding? So I'm gonna check the chat out, just in case anyone responds. Okay. All right. I don't have any responses yet, but I have 2 questions. So I'm gonna wait for, okay. Heather Ali thinks it's a text-to-text model that responds to questions. Okay, that's a good attempt. Leroy thinks it's a neural network that takes input from language and give reasoning answers. Wench thinks it's applied statistics as input text. Darrell says it's ChatGPT. It's like ChatGPT. All right, very sweet. Thank you so much all for participating. A model, okay. Manjunath thinks it's a model that has general information of all things, which can be fine-tuned to various tasks. Ali Heather thinks a language model is a computer program or AI system that understands and generates human language text based on patterns and data it has learned. Ayla thinks human machine language. All right, sweet. So it seems like most of you human chat simulation. Oh, I'm getting really great perspectives here. Any machine learning model classifies something, images, sound, and LLM classifies text and tries to find the next word. Okay, who said that? Juan or Juan? I hope I'm pronouncing your name right. All right. All right. Thank you so much, everyone, for responding. All of you have some perception of LLM. Some of you develop a perception of what an LLM is or what its end utility is by getting your hands dirty with ChatGPT. Some of you actually do have machine learning basics, so you are like, you have a more deeper understanding of what an LLM is doing behind the curtains. Some of you have not used a language model or have no experience with NLP, so you are trying to understand what a LLM is from the different machine learning areas that you have touched. But if put very simply, the way Juan put it, or Juan, I'm sorry if I'm saying your name wrong. A language model is doing nothing fancier than trying to identify or trying to predict what the next word should be, right? It's as simple as that. So the language models were primarily, I would say, they were primarily came into being after transformer architecture was developed by Google in 2017. We're going to talk about that as well. But a transformers architecture that was introduced by Google's DeepMind team in 2017 came like a boom in NLP world, and it took all the statistics-based natural language understanding tasks that were happening, like machine translation or sentiment analysis or text classification. Slowly and gradually, all the tasks were replaced by transformer-based architecture, because the perception was that transformers can do it all. Attention is all you need was the name of the paper. And then the transformer paper basically was introduced with the for the task of translation, language translation. So it was a deep learning architecture which takes an input sentence in a source language and it translates it into a destination language. So from French to English, from German to English, English to German, stuff like that. And how these models were operating, basically, they were autoregressive in nature. That means these models were capable of generating one word at a time by taking all the words that they have predicted so far as an input. So they took their output as a feedback to generate the next word that should be said. Or because if you see the words that are coming out of my mouth, each word has a timestamp to it, right? So the task of speed generation or identifying what is the next word that should come to make the entire sense out of the text that I'm saying is actually a classification task. If I have not made you too confused about it, a language model is doing nothing fancier than actually trying to predict with what is the next best possible word that should come in this sentence. This is what language models were primarily made with the idea of. And if you just bear with me because this is not the right way to put it, but if you just bear with me, and if you increase the number of layers, or if you increase the number of parameters, or if you increase the size of a language model to billions of parameters, now we are not even talking millions, we are talking billions of parameters, you get a large language model, which has been trained on billions of tokens of data on supercomputers by the companies who can actually afford to, and they have open sourced it in form of APIs, and we are actually capable of talking to them. But there's a very wrong perception about what an LLM is. So how many of you actually think that LLM is a knowledge house? And how many of you think LLM is a reasoning machine? If you could drop in the chat, or if you could. Okay, and you think it's not a reasoning machine. It's pattern matching all the way down. Okay. I'm getting some really interesting responses here. It's a statistical model. All right, for sure it is. Stephen agrees with you, Andrew. Both using statistics modeling. Okay, all right. It's an applied model. I don't get that. Problem exists in the definition of reasoning. Oh, how would you define reasoning? Reasoning machine. A large language model is a knowledge house and a reasoning machine. All right, I got some really interesting responses here. So you guys know when Google search engine was initially introduced, people did not. So those of you who actually think that it's a knowledge house, that means you do expect to ask the LLM anything, and you expect it to know the answer to that. And as all of you know, if you don't, I can tell you that if you have used ChatGPT interface, because this is the only one free LLM accessible, and the underlying model that it's using is ChatGPT 3.5, or I guess 3.5 Turbo. So OpenAI, the company which created ChatGPT, they trained the ChatGPT on the data up to September 2021, right? So I hope you all know about that. Now, do you guys think that ChatGPT has seen all the books, or all the papers, and all the research that exists in every single corner of the world up until September 2021? And if you ask it a question about any of those things, it will give you the right answer. No, exactly. That is the point. Then we cannot clearly say that ChatGPT is a knowledge house, because even if we wanted to do that, the data from the point the world was created to September 2021 is not available online. So we'll dive a little bit deeper into what actually ChatGPT is trained on, what are its sister models, and how it actually gets its reasoning and a bit of knowledge capabilities. But yes, the perception of having an LLM as a knowledge house is wrong. Yes, LLM is actually capable of answering questions from a lot of different domains in today's world, but it has been trained on data which is available only in soft or online form. What that data exactly comprises of, we're going to dive deeper into that in a bit. But you cannot treat an LLM as a knowledge house, because if you start asking it some very specific questions, it starts either hallucinating on it, it starts making up facts about it, or it actually gives you an apology that, sorry, I don't know about that stuff, or things like that. So LLMs have to be thought of as a very intelligent, fresh graduate from from Stanford or Harvard. But that fresh graduate, that fresh graduate has like next level IQ. He's very smart. He has taken some very awesome programming courses and has like awesome critical thinking and problem solving skills. But that CS graduate has no information, has no domain knowledge of the problem that you wanted to solve. And that's where LLMs actually shine, because you actually are supposed to connect LLMs with external data for them to not hallucinate, or for them to not make facts up. And there are a lot of tactics when we will talk about actually how to build applications with LLM. I'll dive a little bit deeper into how you should do the prompt engineering, what are some good open source LLMs other than Hugging Face that you should explore, and stuff like that. But just to give you like a high level perception of what LLMs are, you should not think of LLMs as a knowledge house, because they are not. So you cannot expect an LLM to know all the facts that exist out there in the world. I mean, guys, OpenAI is training GPT-5 now, which is multimodal, and OpenAI is not training it on the data beyond September 2021. There is a reason these guys are not training LLMs on data beyond September 2021, because it's not going to make LLMs any smarter. Stacking more layers or making its architecture bigger is the thing that these guys are doing, but they're not increasing the size of the data, because there have been some researches conducted that shows that even the LLMs, the current LLMs, the data that they have been trained on, they haven't even fully extracted all the information from that billions of tokens that they've trained on. Most of the LLMs out there are under trained. So this, and also the compute limitations is another thing because of which we cannot exceed the data limit beyond a certain point. So this is the perception of LLMs. If you want LLM to actually do good on your domain, there is a whole paradigm of which goes by the name of augmented LLMs, in which you actually augment your LLMs to chat with your data, with your PDF documents, with your laws, with the current news, with web information, with Wikipedia, any data that you want your LLM to know to answer your questions better. You have to give it that domain knowledge. And that's exactly how LLMs outshine in the area that you want them to. But this was just a rough discussion of why LLMs are reasoning machines. So, yeah, I mean, I guess we already went through this stuff. So, yeah, this is something very important. Language modeling is something that is considered to be AI complete. If you are aware of DSA and very hard to solve DSA problems, there are some problems which are thought to be unsolvable, like NP complete. And a similar term in artificial intelligence is AI complete, that if we are capable of solving these problems in artificial intelligence domain, then these problems can be believed to be AI complete. And the task that is considered to be AI complete, the hardest one to solve in artificial intelligence, is natural language understanding, and large language models definitely are a step forward towards that. As I mentioned, that we had LLMs idea mentioned before as well, back in 1965, but there have been some AI winters, and that was there because there was some overselling and under delivering. Small prototype based models were very highly oversold, but they actually had very low utilization when it came to actual real world products. So yeah, let's just skip this stuff. They're just actually going through the details of how the type level AI-based products were not usable in the production and real world. And a very simple example is self-driving cars. So we see like very crazy, great applications and very awesome deep neural networks, multi-layered architectures and whatnot for self-driving cars, or for detecting road and lane markings, or for detecting objects or people walking, and a lot of other things, multimodal models and whatnot. But still, to date, we don't see any self-driving cars outside the boundaries of CA, California, right? And that too has happened recently, because there are tons and tons of challenges when it comes from taking a product outside the labs into the real world, because there are a lot of challenges, and that was and these challenges are like really big, and that is one of the problems because of which AI saw its winter, its sinusoidal curve. But we do have a good news now. We finally are actually building products which are used in real world. So we have GitHub Copilot. If you are a programmer, if you code, you definitely have heard of this awesome thing. We have ChatGPT from OpenAI. We have Descript and a lot of other great applications of AI which are actually being used extensively by the world today. All right. Next, this slide deck is actually diving into how to build an application, which I'm not going to dive into. I've shared the resource, so you can actually consult the rest of the slides and the lecture delivered by the actual instructor yourself. Because the audience is a bit diverse, so I want to dive into the second thing over here, which is LLM foundations. So this is the part where we're going to talk about what are some of these state-of-the-art LLMs out there, what are the foundations of LLM that you need to know, and stuff like that. So yeah, I believe this slide deck is going to be super interesting. I won't be going through all the details because of the limitation of time. But yeah, we can start off with this thing and let's see how much can I cover. First off, if you guys have not even heard of machine learning before, there is a software 1.0 and software 2.0 in terms of how Andre Kapathi puts it. So the way traditional programming or software 1.0 works is that, say you're a programmer and you write a piece of code, you write a program, and you give it some input, and it gives you the output as expected, right? There are no edge cases. You designed an app, you designed an Android app, an iOS app, you designed a web app, a driving app, or anything. It's going to follow a whole bunch of if-elses, right? If I just put it that way, and it's going to give you predictable outputs. But when it comes to machine learning, you design a robot, you design the code, you write the code, which is then trained on lots of data samples, right? It learns the patterns from these data samples, and in the output, it gives you another robot, right? Which takes an input and gives you an output. You have no control. It's this robot that is built by the bot that you built in the first place is the one that you have no control of. You don't understand how it is learning the patterns from this data and how it is going to act on all the different edge cases and on all the different inputs out there in the world that it has not seen yet. And that's what software 2.0 basically is. Then just to give a high level idea, we have like main three different types of machine learning: unsupervised, supervised, and reinforcement learning. So unsupervised machine learning is the one in which we just give unlabeled raw data to our machine learning model to kind of learn patterns and structure from it, like language generation or clustering or grouping, stuff like that. Supervised learning is the one in which we map data points and they have labels to it. For example, we have a bunch of images with the label like cat, dog, flower, and then we train a model which looks at an image and can give us a caption. Or we have a bunch of audio clips with their transcription. So we train a model on that kind of data, and then you can give any new clip of audio to that model, and it can give you transcription for that. So these kind of machine learning models are called supervised learning models. And then we finally have reinforcement learning, in which we have an act reward kind of thingy going on, in which we have a bot which actually gets reward if it does the right action, and it gets punished if it does the wrong action. And AlphaGo, a bot from Google, I'm sorry if I'm saying it wrong. I don't remember who built AlphaGo, but AlphaGo was a bot who was actually trained in this domain and was capable of beating Lee Seol at Sudoku game by actually learning the patterns of what right decisions should be taken to win a game. So the reinforcement learning is the one in which we have bots which learn how to act in an environment to actually increase their future outcome, or to increase the chances of their survival. This is the same domain which is actually used in creating self-driving apps as well, to actually decide that what is the right move to take to make sure the car covers the longest distance to earn the highest number of reward points and stuff. But yeah, this is like the high level idea of different machine learnings that we have. We're just gonna converge on the idea of supervised or self-supervised learning, in which we have these kind of problems like text generation, in which we have a sentence, this product does what it is supposed, and then we have a blank. So the model is supposed to predict the next word that should come in the blank, which is to. If I just talk about this part, all the raw text that we have out there, and this is how language models were initially trained, because they did not require any labeling, because labeling happens to be one of the main blocker when it comes to training machine learning models. Because overall, from all these three different types of machine learning, supervised machine learning models tend to perform the best because they have the best labeled data points available. But labeling indeed is a blocker. The more the data, the better your model learns the versatility, and the better it generalizes over the unseen samples. But of course, labeling that big number of samples is a big blocker. The way language models are actually trained is that they don't need any labeling, because let's say if I have this sentence that I want to train my model on, so this is going to be the input, and this word, the next word product, can be the label that the model has to predict. Then this product can be input, and the next word can be the label, and so on and so forth. So auto-regressively, actually, the model is actually capable of putting a mask over the future words and making them the labels for all the previous part of the sentence that can be given to the model as input. And that's one of the reasons we are actually capable of training language models, because they just predict what the next word should be. Or let's not talk about that, because it's just explaining that how images, inputs and outputs to, so it's basically saying that inputs and outputs to a machine learning model is actually numbers. So if it's a raw, very blurred, low resolution portrait of Abraham Lincoln, we are seeing that. But machines actually sees pixels. So each box or block here actually is representing a number, which is a pixel or a color. And all machines or these neural networks see are these numbers out there. So why is this hard? Because there are a lot of edge cases that the world has not seen. So let's say if you train a face detection model with perfectly lit faces, and you deploy it to production, and then your employees come, so that your employees of the company can come in the morning and show their face and mark their attendance automatically. But because of the poor lighting conditions in the production environment, or because of the different lightnings, it's very hard for the model to actually recognize that person as is. So your model can fail on that edge case if it hasn't seen any such faces. Then differentiating between the chihuahuas and blueberry muffin is something that models struggle with a lot. Similarly, the dog and cat classification. And then we also have sarcasm and I mean, I love this movie is a sentence which a sentiment classification model will mark as positive or good sentiment. As good as The Godfather, no cap. Now, it is very subjective. We cannot give this review, this movie review, a positive or negative, because we don't know the person who gave this review actually likes the movie Godfather or actually hates it. Then we have no cap. I don't even know Gen Z language, but I mean, even model doesn't. So the model even has no idea if to label this review as positive or negative. Let's not just talk about these boring details, because I want to dive into the fun part where we have LLMs. Okay, I can talk about this part at least. So what a machine learning model is, or what a deep neural network is, precisely. It started off with perceptron, which is just a vector of numbers which takes inputs. We multiply these input numbers with these weights. We get their weighted sum. We pass it through a function, and then we get another vector in the output, which is then passed through some more functions to give us like a final decision of the task that we want the machine learning model to do. Complicated, and then we can have a whole bunch of layers which is connected to every node in the previous layer, and this gives us this complex machine learning deep neural network. Trying to keep it as vague as layman as possible. And then what a language model is primarily is, it's actually a whole bunch of these nodes connected with each other in a very big, precise, I would say, manner. A large language model is actually made up of transformer architecture, which is not a fully connected neural network, but I'm just trying to give you a high level idea that whenever we say that we have these large language models out there, and we have Falcon 7 billion, and we have Llama 2 coming out with its variants like 7 billion and 13 billion and 14 billion. So what actually is that billion signifying? So that billion is signifying the number of parameters, these weights, which are actually there in a model. So this is a very simple picture, but these large language models have like tons and tons, like billions of these weights, which are learned during training. And these parameters is how we actually judge that how big or small a neural network or a large language model is. So yeah, these nodes are called weights or parameters. And during training, we actually come up with a loss function, which we, as the model goes through the data or sees the training data a lot of times, the loss decreases. Then we have some data set splitting things. Let's just skip that. We also have a whole bunch of pre-trained models available on Hugging Face Models Hub, if you have heard of that platform. And there are like 180,000 models available with 30,000 data sets. I guess that's how they started off with a very humble numbers, but now these numbers have even shot more high. There is an LLM leaderboard available, which is very famous in Hugging Face. So if you are trying to find out which open source model is best for your use case, you can actually go check out Hugging Face's LLM leaderboard, which actually lets you find the best model for the task that you're trying to achieve. It actually helps you choose the state-of-the-art model in that domain primarily. We have Alibaba, Anthropic, ChatGPT, not ChatGPT's variant, of course, they are behind an API. So we have a whole bunch of large language models which are served by these big companies like Anthropic, which has a large language model called Claude. We have OpenAI with its GPT-3, 3.5 Turbo, and GPT-4. And then we have Google's Palm. I believe they have an API as well. So we have all these big giants who have closed sourced their models behind APIs, and we don't have much clue of what's going on behind the curtains. But then we have a parallel research going on to appreciate and to kind of motivate the open source research of LLMs and their commercial usage. So in that, we have Alibaba and Falcon models jumping in. So Alibaba have a whole LLM model series by the name of Qwen, Qwen. So you can go look that up. They have a whole bunch of different variants for code and for chat and for general usage. Then we have, of course, everyone have heard of Meta's Llamas. So we have Llama 1, which was very small. Now we have Llama 2, which has 7, 13, and 40 billion parameter variants available. You can just go to Meta's research site and download the weights from there. They just make you sign an NDA, but now they have said that you can use it for commercial use. These models I know I didn't dive into the part of deploying an LLM app because then that is a whole discussion in itself. But we have a lot of cool tools available out there like LangChain or other tools available which can help you build an LLM application using these open source models. You can choose a GPU. The ones that I tested these models on was an RTX 4090. So I cloned, I'm not trying to make it sound fancy, but I actually had Llama 2 from Meta's research side, and I ran it on RTX 4090. The pattern that I saw in the inference time was that the longer the response of the model is, the more it takes to respond. But average response length with like 15 to 20 words was taking 4 to 5 seconds on that GPU. So if you plan on creating an LLM based app, which you plan on hosting on a GPU, you can definitely go for that. But yeah, these are some of the open source models available out there that you can definitely check out. And for LLMs specifically, there is Hugging Face's open source LLM leaderboard that you can go check out. Okay, that's a lot of background knowledge. All of the things ever since 2017 is transformers. Even in computer vision, not only in NLP, transformers was a neural network architecture that was introduced by Google in 2017, and the name of the paper was Attention is All You Need. It was a groundbreaking architecture that set state of the art on first translation, and now all other NLP tasks like sentiment analysis, text classification, question answering, you name it. How many of you have actually, I've been talking a lot for so long, but how many of you have actually heard of or worked with transformers before? Was the Llama model quantized? The Llama model that I got from Meta's research site, there was option to have the quantized version and have the non-quantized version in the original precision. I used the one that was not quantized, but there is an AutoGPT-Q based quantization available in Hugging Face that allows you to bring down the precision of your LLM to int 8, and it reduces the inference time by I don't know how much because I didn't try that, but yes, you can try that. Right now, LLMs are becoming bigger and bigger. Will there be some time in the future where the models will be smaller? And a very good question. Actually, I can give you an answer to that by showing you a slide that I hope I will get to. But there is a very clear perception, Heather, that no matter how smarter of a solution you come up with, no matter, and this is not me saying, this is a very reputable professor of reinforcement learning from MIT saying, whose name I cannot recall, but I'm referencing it from somewhere here in the slides. You'll find it out yourself. That it's not about how fancy of a technique you come up with. It's not about how smartly you use your data, or how complex of an algorithm you design, or how fancy of a neural network architecture you come up with. It always comes down to, because if you look at the research pattern of how LLMs are actually growing over time, it always comes down to the big guns. Whoever can actually stack more layers and train the model for longer actually gets to win the race. So that's how the research is going for now. Okay. All right. So some of you have mentioned that you actually have heard of transformers architecture before. So which is good. I'm not going to dive into a lot more technical details of what a transformer architecture is. But yes, we have an encoder and a decoder part to it. Encoder part is actually basically responsible for encoding the input that it takes into a form, which is then passed to the decoder. And the decoder takes this encoded input and it generates or spits one word out at a time in an autoregressive manner. And this is primarily what is actually used in the architecture of LLMs as well. I do have a question here, a direct message actually, that people actually want me to talk about how to build an LLM application. So I can actually spend some last 10 to 15 minutes talking about that primarily. I didn't get that part. Okay. So I can just skip the architecture details of what self-attention is, what multi-headed attention is. I can recommend you some good resources. There is an open source blog out there by JLMR that you can go and look up for understanding how a transformer architecture actually works. But Andhra Kaparthi himself has actually given a testimonial for why transformers are the go-to architecture, because they're expressive, they're optimizable, and they're super efficient. And actually, this is a deep neural network architecture which actually took the world by storm, because not only in NLP, but also in computer vision, people started implementing transformers to actually get almost everything done. And that's how it became state of the art in both NLP as well as CV. Okay. Let's get to the part. Okay, should you be able to code a transformer? You don't have to necessarily, because there are some awesome tutorials available online or even on YouTube. This great guy actually builds GPT from scratch. So building the grounds up to actually what GPT is actually just the decoder part of the transformer architecture. And the decoder part of the transformer architecture is actually responsible for generating text one word at a time. And that's how OpenAI actually started off, by taking the decoder part of the transformer architecture, which was given originally by Google back in 2017. And then they played around with that architecture to come up with a lot of different system models like GPT-2, GPT-3, GPT 3.5 Turbo, and nobody knows about GPT-4. So let's talk about LLMs now. And then could you write the resources? You say, I can't understand well the names. Oh, sure. I talked about the Transformers blog. If there is any particular resource that you want me to mention, Carlos, that you missed, I could write down its name. But I mentioned that there is a very great blog post out there by JLMR, which is the Illustrated Transformers. You can check that out to understand how transformers actually work. This is like the most recommended resource on understanding the internal working of transformers. I can't remember. No, I mean the resources to create an LLM project. Okay. Yes, exactly. Thank you so much for sharing, Michael. So let me give you a high-level idea of not BERT or T5, but we can dive right into GPT. And then maybe I can give some insights into how to actually build an LLM application. Yes, I can actually do that. So let's skip BERT and T5 and dive right into the GPT. So GPT stands for Generative Pre-trained Transformer. As I mentioned before, it is just the decoder part of the transformer architecture. And it was the largest model of its time when it came out back in 2019. After GPT, we had GPT-2 in 2019, and it had 1.5 billion tokens, or 1.5 billion parameters. Sorry, not tokens, parameters, in terms of the weights and the layers that it had. If we talk about the training data that GPT-2 was trained on, it had the common crawl, but the common crawl data is actually collected by crawling the websites and different online sites that we have available on the internet, a couple billion tokens. But there were some issues with the common crawl. So what they did, OpenAI actually created their own data set called web text data set, in which they scraped all the outbound links from Reddit, which received at least 3 karma, right? So they were just trying to make a very, I would say, good, they were trying to compile a good data set, because the thing with machine learning models in general is that garbage in, garbage out. So they actually started at a very good point by creating and crafting a good data set to train GPT-2. After deduplication and some heuristic filtering, they were left with almost around 8 million tokens for a total of like 8 million documents for almost around a 40 GB of text. I don't know how much that translates into tokens, but that's what they had, and they trained GPT-2 on it. The encoding that they used, you can actually go on to OpenAI's website and look up OpenAI GPT encoding, and you will actually find this interface as well. Even ChatGPT that you guys use uses byte pair encoding, and that is one of the caveat as well, that if you ask ChatGPT, I think they have resolved it now, but initially if you ask ChatGPT to reverse a string, so if you gave it a query like reverse a string ABCDEFG, it won't be able to reverse it properly, because the way ChatGPT sees the words is not the way we do. So many words actually map to one token. So each color is actually reflecting a single unit that ChatGPT gets to see. So you can see that most of the words are mapped to one token that ChatGPT is seeing, but almost all the time the bigger words are actually divided into smaller tokens. And this is a good approach, because it's a good middle ground between allowing the ChatGPT to learn about the words that it does not naively have in its vocabulary, because it's not possible to include all the words that are out there in the vocabulary of ChatGPT or any language model per se. So byte pair encoding is a very good balance between making new words up. So it actually sees, for the bigger words, it actually sees the syllables, and for the smaller words, it sees the entire word as a single token. So the reason ChatGPT was not actually initially capable of reversing a string, because it was not seeing the string entirely. So if you asked it to reverse the string, it wasn't able to, because it wasn't able to see the entire string as one string, but instead it was able to see it as small tokens. So there were some hacks around it to make it work, but now they use Python programming interpreter to get that done. All right, back in 2020, then after GPT-2, we had GPT-3. It was just like GPT-2, but it was 100 times larger. So now instead of, how many tokens did it have? It had instead of 1.5 billion parameters, we are talking 175 billion parameters. So we can see how big of a jump do we have in the number of layers, in the number of parameters that we have in GPT-3. And since GPT-3 was so big, it was trained on a very large amount of data. And that was the reason it gave surprisingly really good performance on few shot and zero shot tasks. So if you don't know what a few shot or zero shot task is, it was like a few shot task is when you have trained a machine learning model to do something generically, but now you want it to do something else. So you show it some examples, you show it few examples, few shots of that task, and then you ask it to do that, and it's actually capable of doing. So let's say if you have a machine learning model, a large language model, which you have trained on huge corpus of data, and then you tell that large language model that, hey, I have these 3 sentences which are translating from English to French, look at them and now convert this sentence to French. So the model was actually capable of doing really good on such tasks. Of course, there should be some, I would say, data of the target language in the corpus. Otherwise, the model cannot just off the shelf learn French. But yes, the point is the model was also very good on actually classifying text or understanding the sentiment or doing question and answering over a given comprehension, like reading comprehension based task. if we showed it some examples. So GPT-3, when we really increased the size of the network and trained it on a lot of data, the model was actually really good on the few short tasks. Not just few short, it was really good on one shot as well, when you actually showed it just one example and asked it to do that task. And then we have zero shot, that we just ask the model to do the thing that translate the sentence from English to French without giving it any example, without actually training it on that task whatsoever. And it was capable of doing that. So when OpenAI actually increased the GPT-2 size by 100%, by 100 times, and they trained it on a large amount of data, they surprisingly found out that it's doing really good on zero shot, few shot, and one shot tasks. And this is the kind of thing that we use ChatGPT for as well. But the ChatGPT is GPT 3.5, which we are going to talk about shortly. So coming to the point, what GPT-3 was actually trained on, so it was mostly Common Crawl, which is, if you dive deeper into this, this is some frontier media papers. We have a bunch of news articles and more papers, a lot of news websites, New York Times, Los Angeles Times, Guardians, and some Google Patents papers as well. So this was the Common Crawl stuff. So it's mostly Common Crawl. Then we had some scrape links from Reddit. We had some Wikipedia, some selected books and some books from pirated websites like LibGen and stuff. So for a total of 500 billion tokens, the model was only being trained on 300 billion tokens. And same is the case with GPT 3.5 Turbo as well, but the only difference is that the format of the data GPT 3.5 Turbo is trained on. So GPT-3 was just trained on this huge corpus that was scraped from all these resources. So it didn't actually know how to respond to instructions. So if you asked GPT-3 that translate this sentence to English, it will not respond to you by actually translating that, because it's not aware of instructions. It will actually add some thing, or add some response, or append some response to your text, which it would have seen somewhere on the internet, right? Like if you ask it to complete this quiz, it will add some irrelevant text. It will not actually understand and respond, because its data is not of that format. The only difference with ChatGPT is that it also is trained on this kind of data, but the data set was modified to be of the instruction format. And that's what we call, that's where the language models become large language models, because not only is their size increased, we make their data set instruction level. So it's instruction fine-tuned data set that we actually train these large language models on, which make them perform so good and respond to your instructions. GPT-4 is something that we don't really know about. We don't have any clue of its architecture, but we are assuming, given the graph that we have, that since this is the pattern that's being followed. We had GPT-3, we had GPT, then we had BERT large, then we had GPT-2 in terms of petaflops, right? In terms of the number of parameters that we have, we are assuming that if it's GPT-3 at 175 billion and Palm and Chinchilla are the other models by Google and other companies, then we're assuming GPT-4 to be somewhere here in terms of number of parameters, because this is the pattern that we are seeing, that not the number of tokens, but stacking more layers or adding more parameters and building bigger and bigger model is what making these large language models win in the race of AI. So yeah, that's the little lesson, that no matter how fancy of an algorithm you come up with, the more layers you stack, the better your LLM is going to perform, regardless of how good you're doing. All right, there are some more technical details to it. They're talking about Llama and why they're good at few shot and zero shot. And then they talk about Instruct GPT or GPT 3.5. And then they dive into what ChatGPT is and some sister models of GPT. But I guess that's, and then we have some other online models available like Stanford's Alpaca and stuff. But I don't want to dive deeper into these resources, because I think that will be a lot more literature overloaded. So I guess I can take a couple of questions from you guys, for those of you who were kind enough to stick around for almost an entire hour listening to me speak.
Yeah, let's do a couple of questions, and then we don't have a ton of time remaining, so we'll do a couple, and then I have a couple of things I need to announce, and then we'll be done. So,
sure.
right up at the top, and I probably want you to open up the Q&A tab and read them as I'm reading out loud, just so that this one's a little longer, but I'm gonna ask a question from Anisha. So IBM just announced Watson X, and Anisha, I just saw this as well, and I was looking it up the other day. So this model has the capability of translating about 115 other language code. Is this a common trend that we're going to see in the future? And in which case are we going to see a huge shift in software development?
All right, sweet. Thank you so much for your question, Anisha. Yes, IBM did recently announce Watson X LLM model, which can refactor or transform and validate Java-based code. I would say, and yes, of course, it can also has the capability of translating in different languages. This is a very, I would say, as of the details of the research going on that I'm aware of, and I do have colleagues working in even OpenAI as well. So this, I would say, is not the trend that industry is converging towards, because mostly the focus of the tech giants at the moment is converging towards the idea of multimodal LLMs, in which they're trying to equip the LLMs with the capabilities of seeing and hearing, if I may, which will actually allow them to process and understand image data, chat with your data right off the shelf, PDF documents and whatnot, be capable of connecting with a whole bunch of different apps. That's why we have a whole Play Store of plugins of that can actually connect with the ChatGPT or GPT 3.5 Turbo for that case, to extend its capabilities. When it comes to code-based models or multilingual models, I am not sure of the multilingual models. I think Llama can do that stuff, but it's also limited to a specific set of languages that it can talk to. GPT can actually understand a whole bunch of languages as well, and I guess IBM is just trying to come up with that race. But Google recently announced another model which is actually multimodal. So we see the tech giants competing with each other in the multimodal LLM race, because that's where the future is more inclined towards, which is actually giving these LLMs eyes and ears to be more powerful. Stability AI recently also introduced stable code, and Hugging Face has Bloom. So the idea of actually having these code of these LLMs which are dedicated to just code, yes, that's another parallel small race that I say would be going on. But yes, the big guns are more focused on the multimodal LLM race right now.
Perfect, thank you. And then a question from Leroy. How can LLMs perform React without being able to reason?
I don't see the question anyway.
It's in the chat. I'm not, you got to scroll up a little. I saw it in the chat, and so I just wanted to make sure to call it out before I lose it.
I can't find it, but can you read the question to me again?
Yeah, it's how can LLM perform React without being able to reason?
How can LLM perform React without being able to reason? I am not sure. I'm not sure if I understand the question properly. Perform React? I don't know.
Andrew's clarifying. He's saying they may be thinking of programming as in programming in React.js.
Oh, okay, sweet. Oh, all right. So you think, all right. So Nathan, if you're asking that why are LLMs capable of coding or programming, that's because I didn't went to the part in which I had to talk about what was the training data of GPT 3.5 Turbo comprised of, which is the backend model behind the ChatGPT that you guys use. And the data set of ChatGPT 3.5 Turbo was actually scraped from GitHub, which comprises of codes in a whole bunch of different programming languages. And that's why LLMs are actually capable of thinking stepwise and coding, because that's how programs are written. And there's also a small fun fact that code is actually explicitly included into the training data of LLMs, because that have been proven to give them good reasoning or thinking capabilities. So yeah, it's in their training data. That's why they're capable of programming.
And sorry, Leroy, if we didn't get that quite right, but Mamal, we have time for one more question. So,
Okay.
and I think this will be fairly quick. Are
Mhm.
prompt engineering and few shot learning the same, or is prompt engineering essentially few shot learning, just more precise?
So prompt engineering is something that requires, I would say, iterative development. You cannot craft a perfect prompt. You start off simple, then you add more details to it. Sometimes there is a playbook that you go by, and a few short chain of thought prompting is the paper I believe that you're referencing to. And few short is just one technique that you can use when it comes to prompt engineering. Prompt engineering and few shot are not the same things, but you don't need to dive into the details of few shot, because there is a paper which has actually proven that few shot, when you actually give your model some examples and then tell it or ask it to do something, LLMs don't actually perform good at that. Instead, you can just ask the LLM. A very well done zero shot prompt can do really good. So if your prompt is like very descriptive and it's explaining the model by so you need to have a persona of LLM like a junior who doesn't who is very capable and has good IQ but doesn't know anything about your domain. So a very well done zero shot prompt can actually surpass a few shot prompt. And few shot is not similar to prompt engineering. Prompt engineering is just a playbook, just a bunch of tips and tricks to get most out of the LLMs, and few shot is not one of that trips, or I would say tricks out there.
Thank you. All right, so I'm going to steal a screen from you really quick, and kind of wrap us up here. So, thank you everyone for joining today. I really appreciate